Okay. So, Saikran will start the
Mm.
interview shortly. Before that, I would like
Yeah, okay.
to understand like what you have done and try to like introduce yourself a little. Then we'll exactly go to the technical stuff.
Okay. Okay, myself, Killer Cycle. I am currently pursuing MTech second year, VLSI system, Department of ECE, NIT Tiruchi. I am very interesting towards analog. So I am currently doing my internship at Texas. So I have an interview. So prior to that, I have to give some mock interview for you. It will be very helpful for me.
Okay. So, what is like MTech project you have done or you are doing or you were
Okay.
doing before coming here in TI?
Before coming to the TI, in my first year, I did analog related project, the band gap reference circuit design of
Okay.
1.2 volts, which is like
Okay.
extrapolated silicon band gap at 0
Hmm.
degree Kelvin. And the
Okay.
second one is two-stage op amp with Miller compensation.
Okay. Two-stage op amp you have designed.
Yeah.
Okay. And what you have done in the internship here?
Internship, I did the modeling of ESD in Ethernet PI systems. This
Okay.
someone is already designed, but I have to identify some glitches if we give some ESD strikes and all those things. If we give 2 kilo and 1 kilo, 500 volts like that, if we give, even though there are protected diodes and all those things are there, it will get to attenuated to some voltage, but that voltage is still harmful for ICs. So that's why I am analyzing those circuits. If my whatever this my IC is this one, this is bad. If this is bad, the pad and supply is sometimes it may be sorted. Then if I apply any input, how it will behave, whether my output is getting toggle, whether it is how much time it is getting toggle. If it is toggling, how to mitigate those conflicts and how to implement a new design for that one.
Okay. Okay. So what is your role in this in during these 2 months for this?
During these 2 months, normally I am applying some simulations using this real-time RC like charging
Okay.
and some by putting switches.
Hmm.
And I am giving this whatever this input coming here that will be given to this pad and supply shorted
Okay.
input.
Fine. So like according to
Then I am
you, how much percentage of your work you have done in these 2 months? Like you feel satisfied?
Yeah, in these 2 months, they given me two tasks. One task fully completed. That supply and input is shorted. Uh, my output is getting to be toggled for some particular duration. I
Okay.
used my some design methodologies to mitigate those things, and it will work fine. And they
Okay.
will given another thing. The ground and input also shorted. Then apply the input. It is some bit complex compared to the supply and input shorted. So I am working on that one present.
Okay. So it is fine for your interview viewpoint, like introduction viewpoint. Now we'll start exactly with the technical questions. So I
Okay.
think, are you aware about like single stage amplifier, two stage amplifiers? Because you already told that you have designed it, Miller compensated two stage op
Yeah,
amp. Huh?
yeah.
Okay. And also RC, you are well familiar with, hopefully.
Yeah, yeah.
Okay. So I think we should.
Can arrange it.
No, it can be raised, not a problem. It will be raised. Clear the page.
Okay.
Okay.
Mm.
So with the first question,
Okay.
visible?
Yeah, it is visible.
Okay. So magnitude wise, I want to little give you things like it is
Okay.
5
And
milliampere. RF is 1K. For a device, mu s ux w by L, which we call K and S, is given as 200 microampere per voltage square. And the CL you can consider as 10 picofarad.
because
Okay. So the question for you is to plot V out,
okay.
and also I want with the time what will be the region of operations for the transistors,
Yeah.
regions of operation. So you analyze the circuit properly and
Okay.
you can solve it. So question is clear, no?
Yeah, question is clear. Can I consider channel length modulation?
No.
No. Okay.
As
Okay.
of now
First,
you
I will
can put.
plot. Okay. Okay. I will plot.
Let's take
Yeah.
lambda you can take as of now zero, but yes, practicality we can
Okay.
consider also. Later we'll see.
Okay.
First you consider lambda to
Okay.
be
Okay.
infinity. Zero.
Hmm. Okay. Okay. I will write here again the circuit. Okay. Fine. Hmm. I will assume this node will be Vx.
Hmm.
It's not. Okay.
This node already has
This node
mentioned a
will.
V out now. Okay, this is Vx. Okay, fine.
Uh,
Hmm.
then it should be like GMVX current will be flowing through this MOS.
Okay.
Okay. If I apply nodal analysis KCL here,
Hmm.
V naught SCL plus GM times of Vx equal to Vx minus V naught by RF.
Vx minus.
That
Okay,
is the
fine.
thing here.
Okay.
Okay. I can write here also like if I am apply another KCL here, this whatever this input current equal to input current. Okay. That I will get Vx minus V naught by V naught equal to RF into IN.
Okay.
Okay. You know, V naught is V naught plus RF IN equal to IN. Yeah, I will get from here that whatever this V naught will be like SCL plus GM. IN will be 1 minus GMRF.
Hmm.
I will get V naught by IN. The transfer function will be 1 minus
I
GMRF
think
by
let's.
1
I'll give you more space here. Wait.
Okay, okay. This is my transfer function I'm getting.
Hmm. Okay. This is V out by in.
V out by N.
Okay. Fine. Then what? What about V out?
I want to plot.
Yes,
I want to.
you have to plot V out, no?
Okay, okay. Okay, with respect to like in Normally, you are asking in time domain. If
Yeah,
in is
obviously,
going,
with time.
how
With
we,
time, you have to see the V out.
okay, with time. Okay, okay. Like with respect to time.
Hmm.
Okay. Mm, mm, like, okay, it is considered as a one RC.
Okay.
Whenever this high frequency comes into picture, the
I think I forgot
cap
one thing to mention here. Given the VTH is also zero point 0.5 volt for the transistor.
0.5 watts. Okay.
Yes.
Okay. Until unless this node goes to zero point 0.5 volts, the MOSFET will be in off condition.
Okay.
So it will act as a simple RC.
Until or unless this node goes zero point 0.5, this MOS is off. You want to
Yeah,
say that? Okay.
up to this voltage across this gate, 0.5 volts, it will be in off condition.
Okay. So what is the voltage at that node?
So
How will you define the voltage at that node?
here,
What is the initial
here
voltage at
na,
that node?
initial voltage 0 volts.
0 volts. Okay. Then,
Then this will be transistor not comes into picture. This is like a RC with just a step current input.
initially it is 0 volt. How?
We cannot comment about this node voltage.
Hmm. Then, what at when you're applying this step current? Something is happening there, no? How you directly told that it is 0 volt?
Yeah, we cannot say. Step current is applied. This Vout is initially 0.
Why?
After that, the cap will getting linearly charged for some time.
Okay, let's say initially you told that okay, a V out is 0 means capacitor is shorted initially and you are taking the step. Okay, fine.
Yeah, yeah, yeah. It will taking
Then,
step.
hmm,
It will goes to linearly getting charged. Whenever this node voltage will becomes more than 0.5 volts,
okay.
0.5, then this MOS comes into picture. It will draw some current that
So what is the
leads
initial
to
voltage? Initial voltage of gate.
initial voltage of gate. Initial, before that, there will be no current source.
No, no, just when you taken the step, just initial, like after applying the step, what will be
Okay.
expected?
And, okay, you are saying that this current will be
Wait,
when
I
I
should
naught.
give more space. Wait. Okay.
Hmm, I given I naught. Okay, okay, okay. I will say it is like this voltage will be uh, plus minus say not R. Initially, it is I naught R. This voltage,
Okay. So what it is?
this node voltage. Why? Because of initially, whenever step applied, the cap will getting to be shorted. This I naught
Okay.
will be flowing through this one. This will
Hmm.
develop the I naught R voltage across this resistor. So it is grounded. So this node voltage will be I naught R.
Okay, so what is the magnitude of this?
Okay.
Everything is
That
given
I naught you I know, oh, yeah, sorry. I naught you given that how
5
much?
milliampere. 5
Okay,
milliampere.
5 milli. R will be
RF
1K.
is 1K. Yes.
Okay, 1K. So initial voltage across that one will be 5 volts.
Okay.
So MOS to
So
be on after t greater than 0.
MOS to be on. But in which region?
MOS to be on. Okay. That will also tell. The VD is less than the VG minus VTH here. Why? Because of it is of 5 volts, it is zero point 0.5, it is 0 at that time.
Okay.
So I can say MOS is in linear condition.
MOS is in
I
linear
can say
condition.
MOS in linear condition.
Hmm.
So I can say it having some R on.
Okay.
This is the for t greater than 0. This is the circuit.
Okay. Fine. Then what will you say at instants greater than t equal? What will you say at instants greater than t equal to 0? Like you take few instants after t equal to 0 so that you can see what is happening with time for the capacitor voltage in the MOS condition, MOS current. Because we want like 2, 3 instants after t equal to 0 so that you can have the proper visualization.
Okay.
This is the circuit just after t equal to
Mm,
0. But it is not stable
yeah.
at this values only because sometime when cap will charge, something will happen, Rm will change, or MOS condition of
Yeah.
operation can change, everything will
Okay.
change, not with time.
Okay. Our VD is this one. Our VG is zero point 0.5 R. I'm not getting it.
You're not getting space. You want more space.
Not getting in the sense how to approach further.
That is your part. You have to see. I'm giving the hints. We have to see at different time instants and all. We have to see how MOS is behaving and how cap is charging. What is the initial charge? What is the initial slope of the capacitor? And why it is varying, which nature capacitor is following. Is it following linear charging only or is it changing with time? So these are the hints I have given to you. Now you have to approach.
This is slowly developing. Okay. This time, this will be now slowly developing. Whenever this, after some time, T1, so here, 0. Initial slope will be I naught by C, cap voltage.
Okay. What will be the value?
After that, it will charges to linearly.
After that, you will charge to linearly. Okay. Then why your curve is going down if it is charging linearly? You should draw a straight line
Not
now,
linearly.
linear.
It is
Then
like initial slope will be 500 r. Then it will why because of after just t equal to 0 plus this mass is getting to be on. That leads
hmm.
to some resistance path. The current through the cap will not be constant.
Okay.
Okay, it will be vary. So
So what what
the
about the current across MOS? It is also changing or it is constant?
it will also changes. Why? Because of
Or
this VGS is continuously changes now.
okay,
So 1 by mu on Cox that R on 1 by u Cox W by L VGS minus VTH. This will also continuously changes. That leads to different resistance.
okay.
So because of that current drawing through this one also vary. So current through the cap will be also vary. It will charge us linearly.
It will charge linearly.
Not linearly, exponentially. This is exponential. After charging, whenever this VD is greater than this VG minus VT, it will goes into saturation region.
And
This
what will
MOS
happen that
transistor.
what will happen at that time?
That time,
So tell me
these two
what is
constant
happening
are
with no, no, tell me what is happening with current across the capacitor and current across the MOS. MOS current is you are saying decreasing with time.
with respect to time, MOS current you are asking, sir.
MOS current.
MOS current as VGS increasing because of this charging, this leads to this node also getting to be increased. This node potential is nothing but voltage drop across this resistor and voltage across the cap. Cap is getting to be charged. Because of
Okay.
that one, this node is also getting to be goes up.
Hmm.
That leads to VGS increases. So R on decreases means it will take more current.
Okay. So you mean to say this VGS is increasing.
Yeah, VGS is increasing.
Then VGS minus VT is also increasing.
VGS minus VTH also increasing.
Current is increasing.
Yeah.
What do you think? Where this thing will match that VD will go above the VGS minus VTH? And
Okay.
if the diode sorry this MOS demands more current, but we are supplying input only whatever 5 milliamps.
Only five. Okay.
Okay. If
Then
it
current
demands
through the
more, then what
cap
will
will be
happen?
reduces. Current through the
Current.
cap will be reduces.
Is there any possibility that current through the cap can be like going opposite? Instead of charging the cap, it can be coming out of the cap because my MOS is demanding
Okay,
more
okay.
current.
Mass is getting to be discharged. Not mass. This cap will getting to be discharged.
At which point and why?
We are
You
continuously
you
applying.
you initially told that cap current is reducing. It means simply cap is charging.
Yeah.
That's why you drawn the exponential nature now. Because cap current is reducing, so at every coming instant, its slope is reducing. Voltage slope of the cap.
Mm,
It means cap is charging. Then why it started discharging? And at which point of time? Do you really think that cap will start discharging, or the demand of the current through the MOS will not increase such that it should discharge? Will something happen like that? MOS can demand more current so that cap need to supply also, or it will not happen.
MOS can demand more current,
Why?
but okay, MOS can demand more current. Because of that one, current flowing through the cap will be reduces, but direction is in this direction only. I'm thinking.
Okay.
So the charging capability will be decreases. Not it will discharge. It will not discharge, but the charging capability, the slope will be reduces slowly.
Okay. So I got some final charge you got on cap.
Okay.
In that situation, my VG should fix now. Well,
VG
now
also
cap is
fixed.
not. VG also fix.
Okay.
So it means the MOS current is fixed. So why it is demanding
Then
more?
MOS current. Okay.
Why it is demanding more so that you feel that cap can discharge also.
Because of we are because of this I naught current, cap will develop some voltage across this one now.
Hmm.
Earlier, initially it is zero. Because of this I naught current flowing through this one, it develops some voltage across the cap.
Hmm.
That cap voltage and this voltage drop across this resistor is always constant. Why? Because of it is
Uh,
I naught R only.
oh, okay. Voltage across the register is fixed. Okay, fine. What
Fixed.
voltage?
So, but my
What?
cap is getting to be charged.
Hmm. So what will they like?
That voltage, uh,
Okay. Okay, fine.
that voltage
Then
and this voltage, the sum of these two voltages only my gate voltage.
gate voltage. So you told that cap voltage
Uh,
increasing. So gate voltage increasing.
Cap voltage increasing, so that's why gate voltage is increasing.
So it means my MOS is demanding more current to support the VGS.
Yeah, I am thinking so.
Hmm. So you can take some time to think on it because our this session is going to be expired within 2 minutes. So I will
Okay,
launch
okay,
a new session for Zoom after 10 minutes because require a gap of 10 minutes in between.
okay, okay.
So you can think it. As of now, I am stopping this
Okay.
session
Okay.
and we'll connect after 10 minutes.
Okay.
Okay.